Alright, good day, students. I miss you. Sorry I've been out so long, but I keep testing positive, which is a negative thing. I want you to take some notes on this. So there's a handout. If you don't have it yet, make sure you get one. Those of you who are at home, you can do your best to either print it off at home or do your best to fill it in on Cami. Or if you want to wait for it till you come back to get it on paper, that's fine too. Whatever works with you. The first part on the notes, a polygon is a closed. I'm going to need to adjust my pen here. Closed means all the sides connect, so that's no shocker. It's like a math term for that. Is a closed figure formed by 3 or more line segments. Called sides. And when we talk about a polygon in this course, we will always be assuming we're talking about a polygon that is not caved in on itself. For example, we will never look at some kind of polygon like this. Looks like a Star Trek symbol. So they're always kind of bumped out. If you can draw a line through it and the line kind of goes in and out of it, like this one, it is not the kind of polygon we're going to be discussing. So don't worry about that. Okay, the sum of the measures of the interior angles in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. Okay, so an interior angle of a polygon, here's what they're talking about right here. Let's say we have this pentagon, and these are the interior angles. So they're talking about these angles here. If they ever say the term regular polygon in any of these exercises, that means the polygon has all the same side lengths. So before I go to the next slide, you need to remember what's the angle measure of a triangle? If you remember, the angles of a triangle add up to 180 degrees. All right? So let's look at some polygons. We'll start with a triangle that's got 3 sides, and there's 1 triangle in there. So the sum of the angles, called the interior angles, the sum of the interior angles is 180 degrees. Now we look at the quadrilateral, quad meaning 4 sides, and there are 2 triangles. And so if you add up all of these angles, I'm putting a dot on, dot, 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 right? Each triangle has 180 degrees. So if we added up all of those angles together, the interior angles of a quadrilateral is 360. And that makes sense if you think about a square or a rectangle where each corner is 90. Pentagon, there are 5 sides in a pentagon. There are 3 triangles, so the angles add up to 540. A hexagon, there are 6 sides, 4 triangles, and the interior angles add up to 720. Now before we go on, let's see if we can think of a pattern with this. Look at the number of triangles compared to the degree measure. If there's 2, there's 360. 3 is 540, 4 is 720. So whatever the, let's say there's n number of triangles, the sum of the interior angles is the number of triangles times 180. Let me backtrack on that a second here. Now, let's also look at the number of sides compared to the number of triangles. See if you see a pattern there. 3, 1, 4, 2, 5, 3, 6, 4. If we call the number of sides n, what can we call the number of triangles? It's n minus 2. And the sum of the interior angles is 180 times the number of triangles. So it's 180 times n minus 2. If I wasn't homesick, I would be making you figure this out on your own. And we would be, filling this out, and you'll be trying to figure it out on your own, and we don't have that luxury, so let's go on to the next slide. Okay, if n represents the number of sides of a polygon, then, this is the same thing we just talked about. If n's the number of sides, right? The sum of the interior angles of a polygon can be found by doing n minus 2 times 180. So find the sum of the measures of the interior angles in each polygon. So the sum of the measure of the interior angles for a 15-gon, you know what, I'm going to change this up a little bit here, guys. If you used a pen, sorry. Let's do it this way, just because we're used to having things written in this order. So if n is 15, then we would calculate 180 times 13. If n is 21, it's going to be 180 times 21 minus 2. And so on. So I'm not going to finish that calculation. You would finish it off. But I'm going to move on to the next slide to try to keep this video as short as possible. Okay, this slide is talking about the exterior angles of a polygon. Exterior angles are found by doing this. Let's say you have a polygon and you extend the sides, all of the sides, in the same direction. Then what you have here, these outside angles here, those are the exterior angles. So the ones I'm dotting are the interior angles, and the ones outside are the exterior angles. Since these are straight lines, even though my drawing doesn't look very straight, actually let me label that. Let me try to draw this a little bit better here. So if we extend the sides like this, and we have these angles, each exterior angle is going to be supplementary with the interior angle it's next to, because those form a linear pair, if you remember what one of those are. So looking at this example here, if the interior angle is 79, then the exterior angle next to it is going to be 101. If the interior angle is 40, the exterior angle is going to be 140. If the interior angle is 61, the exterior angle is going to be 119. So what happens when we add up all of those numbers? We get 360 degrees. All right? You should try it on the quadrilateral, the same thing I did with this triangle. Go ahead and pause the video and try it. Find the angle measures of all the exterior angles for this, and then add them up. And you'll see they equal 360. Okay, and then you know what? These are just two more examples of the same thing. What you're to do is go through and just to check the conjecture that the sum of the exterior angles is 360, try it on these shapes too, and it's kind of cool. What you'll see is that every time, no matter how many sides the polygon has, the sum of the exterior angle measures is always 360. So I'm not going to take time to fill those out, but you should do that. Okay, it'll give you good practice too, remembering what a linear pair is. And what can we conclude about the sum of the exterior angles of a polygon? They always add up to 360 degrees. Let's call this, oops. I was going to say the sum of the exterior, and I realized I shouldn't abbreviate that. Yeah, so let's just call it sum of the exterior angles is 360. Okay, so let's tackle some examples. What are we going to do with these two? Or actually, these examples have to do with exterior angles. So look in the problem and read it carefully. Okay, it says, what is the measure of each exterior angle of a regular hexagon? When you see the word regular, it means all the sides are congruent. In other words, all the sides have the same length. And this says, what's the measure of each exterior angle? So the sum of the angles is 360. How many sides does a regular hexagon have? Hex is 6 sides, all right? 6 sides. So there's 6 exterior angles. So we'll just take 360 and divide it by 6. So each exterior angle is 60 degrees. And number 8 is similar to this one. So let's go on to number 9. If the exterior angle of a regular polygon is 12 degrees, how many sides does the polygon have? Well, we know the sum of the exterior angles is 360 degrees. And we know that each one of those angles is 12. So basically, if we take 360 and divide by the number of exterior angles, we're getting 12. So we will solve this equation. 360 divided by 12 is 30. So this polygon has 30 sides, which we would just call a 30gon. Once you get past like dodecagon, once you get past 12 sides, or even 10 sides, a decagon, usually we just say however many sides and then put gon after it. On this one, if it, so we take 360 divided by the number of sides, gives us the measure of each of the exterior angles. So this one is measuring 40. So we solve this for n. We'll divide both sides by 40. And that gives us 9. Okay, so to sum up the formulas you need, the sum of the, let's change colors. I'm tired of red. It's too correction-y, you know? The sum of the interior angle measures of a polygon is going to be 180 times the number of sides minus 2. The sum of the exterior angles is going to be 360 degrees. So the interior angle measure of a regular polygon would be whatever the sum of the interior angles is divided by how many angles there are. So that is the measure of one of the interior angles of a regular polygon. Exterior angle measure of a regular polygon would be 360 divided by the number of sides. The number of sides of a regular polygon, not sure what they want us to put on that one. Hold on a second. Yeah, so the number of sides would be 360 divided by the angle measure of the exterior angle. Okay, some more examples. What is the sum of the measure of the interior angles of a pentagon? Pentagons have 5 sides, so I'm going to write, okay, my n is 5, so I'm going to use that formula. That's going to be 180 times 5 minus 2. That's 180 times 3. Which is 540 degrees. I don't have much space on here, but that's what it comes to. Number 2, what's the sum of the measures of the interior angles of a 27gon? So we've got 27 sides, so it's going to be 180 times 27 minus 2. Go ahead and you can finish that calculation. Number 3, what's the measure of each interior angle of a regular octagon? So the number of sides is 8. So we're going to find the sum of the interior angles, and then we divide by how many interior angles there are. And then you would calculate that. So it'd be 180 times 6 divided by 8. Number 4, what's the measure of each interior angle of a regular 20gon? So there's 20 sides. The sum of the interior angles would be 180 times 20 minus 2. And then we divide by 20 to find the measure of each one. Let me grab a calculator and I'll finish this calculation. So let's see here. We've got 180 times 25 is 4,500 degrees. And then this one is 180 times 6 divided by 8 is 135 degrees. And then number 4, we've got 180 times 18 divided by 20. Okay. Okay, so today I just wanted you, this video is long, so this is your assignment today, is get this down on notes. Tomorrow I'll give you some practice on this, so you're going to want to have some examples written down in your notebook, so you're going to want to have this paper handy, okay? I don't want to overburden you since I'm not there. Some of you have not watched any of the videos I posted. The other day I looked and there were 6 views on one of them. This is your assignment. You have to be in class for 53 minutes. You need to do the assignment. Okay, so when you're assigned to watch a video and take notes, you need to be doing that. Okay. Have a great evening. I will talk to you later. Hopefully I'll be back soon.